In this session, I'm going to introduce you to the robotics lesson plan PDF found in the EV3 tablet app. So let's start by picking up the tablet and loading up the lesson plan material. So go to the menu at the top of the screen and I click on Teacher Support and I click on the Lesson Plan tab. And I'm just going to scroll down to the table of contents and just explain what we've got here. So there are 7 lessons for the students to tackle. The first lesson is about building and setting up the robot with the app. And the following 6 lessons are linked with the Robot Educator tutorials. And they follow the process laid out. The objective, the build it, animation, test and modify. And then once the students solve the modify, they move on to the lesson challenge ideas. And there are normally about 3 challenges for them to undertake. This takes their learning to a new level. Each of the lessons has resource maps or sheets that can be photocopied, enlarged, or if you really wanted to get into the mathematics side, you can measure out the courses with a ruler, pen, protractor, and tape as well. Each lesson has assessment criteria that allows teachers and students to measure what they have learned and how accurate they were with their tasks. Now let's try one of the lessons. We don't have time to do all of it, but it will give you a taste of the materials that have been created by LEGO Education. I'm going to make some assumptions here so that we have learned how to move our robot by going through lessons 2, 3, and 4 using a variety of techniques. And in lesson 5, we are introduced to the gyro sensor. Now the first thing we'll do is we'll run through the stop at angle tutorial and show you how that works, and then we'll come back to this lesson plan. So just click on close and close again. We go to Robot Educator Stop at Angle. So here we start off with the video to show what we're going to do. So we're going to drive our robot, we're going to turn it 45 degrees and move off in a straight line. That's our challenge. We've already built it, so we don't need to add anything else. I've got my gyro sensor connected already. And I can have a look at an animation to see what's going on. Here I'm turning, then I'm moving in a straight line. So, if I now test what's already here, I click on Sample Program, and the program loads into the canvas area. So let's run and see what happens when I press play. Okay, let's try that once more. So we'll put it straight ahead here, and let's see how good a 45-degree turn we had. Now that's a pretty good 45-degree turn. Maybe it's an angle too much, 1 degree too much. Now this is where we can learn about the gyro and how it works. Now a gyro has some degrees of inaccuracy, it can have, so it does mean that we have to edit our 45 degrees, maybe 1 degree either side. So that's something you have to test and you have to try out. So let's change it to 46 and let's try it once more. Wow, much happier with that. Now, looking at the modify task, it then says make the robot turn 90 degrees and have it drive in a square using as few programming blocks as possible. So here, this increases our learning. This takes learning to a new level and gets the children to think about how they have to use the gyro to get that 90 degrees turn. So once we've done that, we can then go back to our lesson plan, and I quickly find my lesson 5 and show you where the students move on to next. So here we are, and if I scroll through the lesson plan, what I love about it, you get the objectives to the session, how long the lesson is going to be, the preparations needed, and then the procedure. First of all, by going through the tutorial, stop at angle, and once we've done that, we move to the lesson plans. Now, one thing to point out, there is a troubleshooting section in this lesson plan because gyros sometimes can drift. We call it drifting, where the angles move around, and it tells you here how to reset that. Now moving forward, or moving down the page through the lesson plan, there are 3 lesson challenges here. The first activity asks the students to write the letter Z or Z with the robot. So that's really thinking about angles and what angles we need for the letter Z. And then the second asks the robot, or asks the students to make the robot draw a star. So again, lots and lots of maths work on angles. Now the final activity, which is the one we are going to do, is all about navigating around a course. So we're going to have a go at doing this. I'll do some of it live, and then I have got one I prepared earlier. So let's have a go. So I'm going to close up my lesson support, and I'm going to start a new program. I'm just going to put my iPad down for a second. And what we want to do is drive around the course and park the robot in the red area here without knocking over any of the minifigures. So we can take all of the knowledge that we've learnt before and apply it in this task. Now I set this up myself by going through the PDF, looking at the measurements. I measured and marked out the course. Another great maths exercise on measurement here. So I've written up on the board what 1 rotation is, 17.5 centimetres, what 2, 3 and 4 rotations are. So if I measure here from the centre of the wheel, make sure my tape measure is the right way round, and if I measure down to here, that's 70, and that's a pretty good place to stop. So I know that my first block is going to be driving in a straight line for 4 rotations. So let's see what happens. Hit the play button. I'm pretty happy with that. So what do we need to do now? Well, we need to now turn 90 degrees to the left. Now we could try and do this as one activity. I like to do a little bit of testing all the way throughout the course. But once you get used to the software and you're confident with it, I'd set the challenge to the students, try and do it in one go without any testing and see how they get on. So what do we need to do now? Well, we need to do a turn. So I'm going to bring in my move steering block. I'm going to tell it to turn to the left. And now I want the turn to be controlled by the gyro. So all I'm going to do here is turn the motor or the move steering block on. So now I need to put in a wait for gyro to turn 90 degrees. So I change it to the gyro, and we're looking for a change of 90 degrees. Now what happens once we've turned 90 degrees? Well, I want the motors to stop. So I do need to bring in a little stop, or off as we call it here. And then what do? We test it. We see how that works. So I bring my robot back to the starting point, and I press play, and let's see if we get a good 90-degree turn. Wow. Now, as you see, it's really pushed around 90 degrees, and there's an important reason for this. Really good teaching point for you as teachers to let your students know. The speed of the turn was too quick, so let's slow the motors down and see if we get a much more accurate turn. So we put it again at the start, and instead of being speed 50, let's power it down to speed 15. Let's see if we get a more accurate turn. So press play, download and run. Should be slower now. That's about 91. So remember what I said, sometimes we have to play around here with the parameters. So I'll put in here 89, and hopefully I'll get a good 90-degree turn. Because remember, there is a slight variance in the accuracy of the gyro. So what now? Well, I'm going to add another block, and I'm going to drive my robot now along the table. Now, if I now bring my tape measure down, 35 is about here, which is quite nice. 2 rotations, okay? So that's important to point out, 2 rotations. So now, I'm going to drag in another block and drive for 2 rotations. So let's see what happens. We press play. It downloads and runs. Okay, brilliant. Just to save a bit of time, I'm going to bring up the program I did earlier. Let's see if my robot can get around the course and park. So I'm going to go back and bring up my gyro task 3, and you can see I have a program now that's twice as big, and we're going to download and run this and see if I can get around the course without knocking any of the minifigures over. So, fingers crossed. Here we go. I knocked just one out of place. Okay, that's not bad. It wasn't knocked over, just a slight knock. Okay, I'll put that back in there. So I managed to get around the course, and I managed to park my robot educator model in the parking bay. Now, moving back to the lesson plan material, it's important here just to finish off. If I move down to lesson 5, what I like here is after the tasks, there is a whole series of assessment opportunities. So what is great is that the assessment paragraph describes the objectives. Can we identify factors that might affect the stopping position when using the gyro? So yes, we noted the drifting and also that there can be slight inaccuracy. Can we manage to describe robot behavior in relation to the program in as much detail as possible? And in the modify it task, can we make the robot drive in a square based on the gyro sensor input? Now, in the lesson challenges for this particular lesson, can you fully or partially draw the letter Z or Z? Can you draw the star? And the one that I did, can I fully or partially navigate the robot through a maze? Now, other assessment opportunities here is, can we work cooperatively to solve the task, can we? Because we always do these activities in pairs. Now, by the end of the lesson plan, you will find relevant standards as well. So it's important that depending on which country, those standards are going to be slightly different. But the purpose here is to show where our material can fit into the different curriculum areas. Now, depending on your outcomes, the bullet list could have different areas. It could be computer science, it could be computing, it could be computer studies. For example, though, we could cover the following standards for the lesson that we've just done. We could use standard input and output devices to successfully operate computers and related technologies, yes. And we can apply strategies for identifying simple and hardware and software problems. Now, with the gyro, that could have been one of those things that happened. So what else do we have? Let's look at some of the other challenges in the material. So what I want you to do now is pause the video and have a go at one of the lessons yourself.